Hi there, welcome to my channel again. I'm Vox Machina, and today we're going to be talking about yet another model of my do-it-yourself series, a voltage control LFO with 4 waves output and a reset input function, as well as a coarse knob for you to tune it as you please. So let's gonna build it together, and then we're gonna do some sound demos for you to check it out in detail. Remember, all of my projects are available on my GitHub page as an open source project, so please feel to follow the links on the description and start soldering away a little bit yourself and have fun. Thank you. So we're gonna build a Cha-Cha or LFO. Here's how it looks like. I'm also experimenting a little bit with the LEDs and the front panel with the FR4 material, so let's see how that goes. So, you know, my process, I always start with the front board, the control board that has the jack inputs and the knobs. First of all, I'll organize my boom sheet I have in front of me, so I can keep track of what I'm doing and the materials that I'm using and make sure everything goes into the right place. So as usual, I'll start with the resistors. I'll put them on top, just give them a notch of soldering on top, and then move the board to the back, trim and adjust soldering on what needs to be adjusted, and continue to the diodes. Start from the smaller pieces to the bigger pieces. It's easier for me at least. So you want to be careful with the transistors, they are very close together, so just make sure you push them down until they are a little bit over the PCB. Always leave a little bit of a space, turn them around, make sure to separate the legs a little bit, give you some room to solder, and be very gentle with the thin solder pointy. You shouldn't be able to make this, but just a little bit of solder goes a long way. Now we can start preparing the socket for the TL072, the op-amp. Just make sure all the legs are aligned, and make sure you bend them just a little bit on the table on both sides, so it's easier to put them in the socket before soldering. So now we can start with our bigger elements, the knobs and the jack inputs and outputs. The way that I prefer to do it is to just mount them first, take out the nuts, take them all out, just mount them on top of the board, and then add the front panel and close the front panel a little bit, how we will end up in the end, like it was finishing up now, and then turn around and solder the elements. This way I make sure that they stay in the right position when matching with the front panel. And then I'll have to take the front panel again out to finish the soldering and the testing. So yes, of course, I'm using this front panel as an experience to make the LED beneath it to somehow pass the light up to front, but of course I forgot to solder the LED. So just a note, when soldering the LED, the idea is that the tip of the LED is touching the back of the front panel, so that the light will reflect upon the front panel through the little window of material that there's in there. So now all that's left to do for this control PCB is the pins that will connect the two boards afterwards. The way that I do it, that I find it useful for me, is to add these pins to the board first. Attempt to put the board on top of the table with the pins down below, like supporting the board. And then, at least for me, it works. This way I make sure they are standing in the right position. So I'll just solder maybe 2 counterpoints, and then if needed I just move it around to solder the rest. And that's pretty much it for the control board. Quite an easy build here. Now let's jump to a little bit more challenging board, the main board, where we'll see how we solder our resistors in a vertical form so that we can achieve this 6 HP size for this LFO. So now let's start with the main PCB. This one is a little bit more tricky because it uses a lot of vertical resistors, but if you follow this process, it's guaranteed to work. Keep in mind, I learned with about 2 or 3 of these that failed. One of them, the top of the resistors were touching the control PCB board, so be very careful when doing this. I will show you how I do it, and hopefully if you follow these instructions you'll end up just fine, just as me. So what you want to do is to pick up the resistor and just bend one of his legs down, like with a very, with a very small height if possible, or as much as possible. I mean like this, so that we make sure that the top of the resistor right here will not touch the other PCB on top. And it's just it. You just need to be careful and insert them a couple onto the board. Solder a point on top of the board that is not directly connected, the one that is more far away, and then turn the board around, solder the other joint and trim, and that should be fine. The only concern here is to make sure that your resistors will not touch the control PCB board when added on top. So make sure you really blend these resistors really close, tight, with the minimum of height as possible. And then, believe me, after you do the resistors, everything else will be really easy for you. It's always the same process, the sockets for the ICs, the capacitors, it's always the same flow, so let's just do it. Keep in mind, one very important thing to keep in mind, the power connector connects towards the back. So please, that's the only element that connects towards the back, unless you're using these 47 UF capacitors for the power area that are a bit taller than the space between the boards. You can always assemble, solder those in the back as well if you need to. I try to make sure all the elements in the board have a very fast, quick to read label, so that you can just mark it on a boom file done as you go. All the resistors have their direct value on board. The power supply section has a stripe of white indicating where is the -12. The ICs have the IC label text also in the space inside the IC, so it should be really easy to follow, but I always like to keep at hand, at reach, the boom file, the PDF with the instruction that I also have on my GitHub, and do let me know if there's anything wrong or anything missing. So now I'm going to add the pins for the boards to connect together. The way that I like to do it, I like to stick them on the other board, which is already soldered, feed in the board to be soldered on top of the pins, and then you just need to solder them because they are already in the right position. It makes it easier for you. That's pretty much it, you know. This is a simple model, voltage control LFO, which I don't see often. I don't know why. I see a lot of complex LFOs for sure, but I really want to have frequency modulation control of the model, and I really want to have a reset input, so that's why I did this in the smallest amount of space that I could. It's 6 HP, I think it turned out pretty well. As you can see here, just make sure none of the components are touching the board, because we have a lot of vertical components on this one, and it should be ready to go. Now let's put our front panel again, tighten everything up, and let's jump into some demos, see how it sounds, and first of all, if there's no magic smoke coming out, please. So that's it. It looks like we have our model assembled. It's time for some testing, and let's see how this LED performs. Let's see.